Okay, I hope you are. Good evening, everyone. My name is Alexander Ryshkov. I am Location Lead and Delivery Director of Grid Dynamics. Welcome to the Dynamic Talks Meetup. So Dynamic Talks Meetup is a global meetup series featuring tech talks on technologies and presented by experts in major United States, Central and Eastern Europe cities, as well as in Zoom, starting from today. So thanks so much for joining us. A little bit about Grid Dynamics as a host of this session. I'm proud to say that Forrester named Grid Dynamics a leader among mid-size agile development service providers. And nearly 30% of our team are big data specialists who implemented data quality, data cataloging, and lineage at Fortune 500 company, increased overall enterprise trust in data and in big data as well. So let's get to the event. We have got awesome speakers today, and I'd like to introduce Vladimir Baev, our senior big data developer, who will start orchestration with the Apache Airflow. So Vladimir, I'm passing the spot to you.
Yep, thanks, Alexander. So just give me a second, I'll share my screen. Okay, can you see it now?
We can.
Okay, great. Today we are going to discuss big data orchestration with Apache Airflow. And just before we start, just a few words about the format. Zoom provides us with functionality of this Q&A. So during my talk, feel free to post your questions directly into the Q&A section, and later today I will do my best to answer all the questions. So let's get started. Okay, as you know, the main thing in big data is that data is really big. So we have a lot of different storage systems. We have a lot of processing engines. Also, amount of applications increases, and all these applications have dependencies. Sometimes they are non-trivial, and in this case, it's obviously that we need orchestration as a way of connecting different components of applications to provide appropriate scheduling and interaction between these applications. Imagine, for example, you have a sequence of Spark jobs, and each job actually takes output from the previous one, then it performs some kind of processing, and as a result, it sends output to the downstream system. In this case, we need orchestration, and I'll help you with that today. Basically, I'm working in a tech project. It means that we have real complex cases for orchestration, for batch processing, and for machine learning as well. Today we are going to cover orchestration in big data. Then we will have an introduction into Apache Airflow, and after that we will cover cases more related to production and real-world systems, and also we will talk about extensions for Apache Airflow. Okay, and a few words about our project. It is an EdTech company. It means that our goal is to provide appropriate advertising for the clients, for particular users. So we have a lot of input data. Then we are gathering all this data from different sources, calculating metrics, applying our machine learning models. And as a result, we have these metrics, we have reports, which helps our clients, to determine how they could potentially improve their advertising campaigns. So, we have quite high volumes of data, and in such constraints, orchestration might be a real challenging task. So today we'll talk about it. And speaking about orchestration in general, we have these basic requirements for orchestration system, such as it should support different input sources, it should be reliable enough, it should work in a distributed fashion, and of course it should be fault tolerant and flexible enough to handle all the production workloads. And now there are a lot of different solutions in the market. So some of them provides rich sets of features. Some of them looks like simple grown-up expressions. But anyway, you could choose appropriate solution for your case. And here, I was thinking about just ask if any one of you used previously Airflow or another orchestration. But with this webinar format, we will do it in a little bit another way. So let me just post the link, give me a second, to this survey. Okay, and yeah, you should see now. So please submit your responses, and later today, after the talk, we will just reiterate and review the results. We will figure out which orchestration tool is the best. So yep, I'm waiting for your responses. And speaking about our particular case, we had a lot of applications in different projects. Also, I'd like to mention that the code base of applications varies from 1 month to a few years. So we had a solution with basically some kind of mix of various orchestration tools spread across different clusters. And of course, from some point, we faced issues with maintainability, with restatement of applications, so support from both data engineering sides and the support teams become non-trivial. And we were aimed to figure out the most reliable orchestration tool for our case. And we've tried to use Apache Airflow. And I'll describe how it goes in our project. So let's just briefly cover main points about Apache Airflow. So it is an orchestration tool which uses Python DSL for defining the pipelines. And regarding basic vocabulary, let's define main points. So imagine you have a business application, business task, which might be split into separate units of work. So in this case, we could represent our business task as a DAG, I mean directed acyclic graph or the pipeline. And each particular pieces of work actually in Airflow named as tasks. So the DAG defines the relationships between the tasks, and also when you execute a particular task in Airflow, each task execution named task instance. And speaking about tasks, we could split them into two different categories. The first category is operator. Operators basically performs some kind of work for us, and sensors are mostly waiting for input events. And one more thing regarding DEX, there is a concept of DEG runs, which actually represents the instance, the execution of particular DEG. And just a few words about architecture and infrastructure. Our nodes in Airflow might be separated into master nodes and worker nodes. And we will cover it later today in a little bit more details. And one more thing to say about Airflow is that initially it was designed as batch-oriented orchestrator. So, for example, if you are going to orchestrate real-time processes, then probably Airflow is not the better solution for that. But anyway, it depends on particular case. Okay, and one more thing, since we're defining our pipelines as a Python code, it really provides us flexibility and a set of useful features. So we'll talk about it further. And here in the right side of the slide, you can see example of simple DEG with structure of the DEG, and a few words about Airflow API. Also, here is a view and you can see all the DEGs with their statuses. And here is a tree view where you could track the history of DEX executions with their statuses as well. And here is a model window which allows us to get logs for particular tasks or get input, output parameters for the tasks as well. Okay, and let's describe other major concepts of Apache Airflow. So as I mentioned before, it have operators and sensors. And also, since Airflow is an open source tool, it supports a lot of various operators. For example, it has Bash operator, Python operator, and also with these operators, you could define the structure and behavior of your DEG. For example, you could define branching logic or even trigger one DEG from another one and wait for completion and so on. And also, if you need prioritization logic on your tasks, you could use pools and queues for that. So, yep, Airflow have pretty flexible capabilities for that. And also, if you have some external systems such as databases, data warehouses, you could also use hooks, connections for that. Also, if you need storage for parameters, Airflow also has such functionality, and we will cover it today as well. Okay, and here is an example of a simple Airflow DEG. So as you can see here, we define our DEG with particular name. We set a schedule interval for that. So with this cron expression, the DEG will be triggered every 5 minutes. Also, here we have a simple bash operator, which executes date command. And here is a Python operator, which just executes this print hello function. And in WebUI, our DEX looks in the following manner. So we have we have two tasks. And here in TreeView, we could track history of runs. We can see that there were 2 successful runs and 1 run is still in progress. And here's an example of log for a particular task. Okay, then let's cover how Apache Airflow works in production in real world. And you know, in order to build application, we need these steps. So first of all, we have to define our business logic for our application, and let's describe it with example of machine learning pipeline. So imagine you have 2 separate pipelines, the one pipeline for training of your model and another pipeline for particular getting predictions from the model. And when we are going to build new model, first of all, we are gathering training data sets, we are making some data preparation, then actually we are building our model, release it somehow, and after that we are ready to get predictions from the model. So for example, if you have batch processing, we are waiting for input data. After that, we also might need some kind of pre-processing for the data. After that, we are applying our model, and as a result, we have scored data, which basically might be exported into some downstream pipelines and systems. Okay, so we defined our logic for application. Then let's talk about infrastructure. Here is an example of Airflow setup with salary executors. So as you can see, Airflow have master node. And here we can see the process for Airflow scheduler and also Airflow web server, which provides us web user interface. And we have a bunch of worker nodes, which actually salary executors. Also, here we have message queue, you know, in order to have interaction between master and worker nodes. So, for example, when we have a new task, the master node just sends it into the message queue. Then worker node extracts task from corresponding queue, performs the processing, and just reports the result back. And also here is an Airflow database, which used for internal Airflow processes, such as managing of state and other meta information. And I would repeat myself that this particular setup applied to one particular team. So you could have another setup, and in our case, we have 3 Airflow clusters for dev, staging, and production environments. And each Airflow master have about 20 Airflow workers. And we have about 200 of decks on each environment. And one more thing regarding management of dependencies for Python, we have virtual environments for that on master and worker nodes. So we are using them basically for managing of Python packages. But if you need more, you could use Python virtual operator in order to provide some custom dependencies for a particular task of the deck. Okay, and one more thing about infrastructure and related challenges. So recently we had a migration from the one version of Airflow into another. And in this migration, we we've updated our pipelines, I mean logic, slightly since the API changed a little bit, and also it required some amount of work from infrastructure team, since they have to migrate databases, update the schemas, and so on. And one more migration, which we had recently, is migration from the Python 2 into Python 3 version. And in this case, we also replicated our existing infrastructure, but we partially reused infrastructure, I mean workers, and actually one worker used for Python 2 and Python 3 versions in parallel. So with this approach, we saved some amount of resources in terms of virtual machines. And one more thing about migrations in future. So Airflow 2.0 will introduce new API, and we will lose backward compatibility. So if you're going to use Airflow in production, you just should keep it in mind that you will have to perform a reasonable amount of work in order to migrate into this new version. Okay, and one more thing regarding infrastructure and Airflow integration capabilities. So as I mentioned, Airflow have different types of executors. Some of them are suitable for local testing and development, but another ones are pretty stable and works in production systems without major issues. Also, I'd like to mention that Apache Airflow have good integration with cloud providers. And as for interfaces, it have command line, also REST API, and you could use Airflow internal database for your purposes. Okay, so we have an infrastructure, and then it's time to build our application. And Airflow provides pretty useful features for that. First of all, let's talk about configuration. So imagine you have a machine learning model, and of course, you have some configuration, for example, variable which stores threshold for the model, and you have different options to store this value. So first of all, you could simply hard code it into your pipeline and store in repository. But in this case, if you're going to update the value, you have to redeploy your application. So if you need a more flexible solution, you could use Airflow variables for that. So it provides simple key value storage, but you should keep in mind that it doesn't have any audit capabilities. So it means that for production critical parameters, probably you should go with the approach of storing into repository. But anyway, it mostly depends on your business case. And the next major thing about Airflow and the Python DSL. So it allows us, as you can see in this example, just with a few lines of code, define a really complex dynamic structures for the DAGs, and you will not have any duplication in configs such as XMLs or another configuration files, since you could just dynamically define your structure. And the related thing about the DAGs. So here's an example where you could easily build, define, and create a lot of DAGs from basically one source file. And it might be useful, for example, in our case, we have different clients, and we are splitting our pipelines, our logic by the client IDs. So in this case, we have just one pipeline, and we are generating dynamically various pipelines just by this client ID, which might be taken from database, for example. Yep, and with this approach, we have a clear history of all the runs for DAGs of particular clients. So yeah, this approach is pretty useful in our case. Okay, then, of course, before deploying our application to production, ideally, it would be nice to test application. And what we have here with Airflow. First of all, it allows us to perform development and testing locally. I mean, we could either have a standalone installation in our laptop, or even we could use official Docker image for that, and easily launch the DAGs from our local machine. And also with this concept of unit testing, we could perform basic checks such as the structure of the DAG is the correct as expected. Also, here is an example where you could easily test a particular operator. So we are creating task instance, execute it, and then just validate that result is correct. And if you need testing, more from real world on real systems and integrated with your external systems, you could first of all, you could use separate DAGs for testing. I mean, we will have one DAG which will test another one. And also here, REST API would be helpful, since we could trigger our DAGs with it. Also, we could monitor state of our DAGs, monitor statuses, and retrieves the logs from workers and just validate outputs. Okay, so what's next? Then we have to deploy our application. And of course, we should manage our versions of applications somehow. So first approach is just updating the name of the DAG when you are bumping the version up. So basically you have this version in the name. With this approach, you will completely save all the history of runs. But for example, if you have some external systems which relies on this name of your DAG, then probably you should manage this actual version somehow, and just ensure that it points to the latest version. And another approach, if you are going to have the same version, then you could, of course, update the structure of your DAG. But here also might be the case when, for example, you completely reorganized your DAG and removed some tasks, updated the dependencies logic. So in this case, you will lose all your history for the previous runs if, for example, you deleted the task. So here, in example, we can see then we've added this print another hello task, and we have so we have empty tasks for the previous runs, but when you will delete, then the deck will not contain these tasks at all. But for example, if you are going to update the business logic without modifications in DAG structure, you could just go with approach of having the same name, since the structure is the same, so it will work in this case. So again, it depends on particular business use case. And one more thing regarding DAX deployment and management. So when, for example, we have this setup with salary executors, then during deployment, you might have already running DAX, but then you just deployed the new version, and this running pipeline might fail just because, for example, the file no longer exists in the file system. So in order to handle this issue, you could use Airflow internal database and track the status of the DAX and handle it into in your CI/CD process. I mean, make some preparation, just pause the DAX, then proceed with deployment, and after that, continue just resume your DAX. So Airflow database might help you in this case. Okay, then when you have your application running in production, probably you need some tuning of parameters in order to optimize execution time. So in Airflow, you could define concurrency parameters for tasks, for workers, or for DAX. Also, Celery provides configuration for queues itself. And one more thing about Airflow ignore. So we used this approach just to hide some locations from the process which scans the DAX folder and imports the DAX. So in our case, we had other Python packages near the pipeline. Also, we had a bunch of jars dependencies. And when we moved these locations into Airflow ignore, the time of scanning all the DAX reduced from just 10 seconds to something like a second. So it was a pretty nice improvement from perspective of overall performance in our project. Okay, and the last thing, you know, for support, you should have appropriate monitoring. And Airflow also has a bunch of features for you. First of all, after failure of the task, it could send an email to define the list of users. Also, it have timeouts for tasks. You could set up a number of retries for tasks. And also, you could set up handlers for SLA misses in your DAX. And also, Airflow has a separate view in the web UI where you could manage and see all your SLA misses and handle them somehow and just track them. Okay, but what if you need even more? Then you have to extend Airflow with your custom operators or hooks or even elements of web UI. For these purposes, Airflow have this concept of plugins. Basically, you have to define a Python file with all the custom content inside and just put it into corresponding location, and Airflow will automatically import all these operators and features, and they will be accessible by other DAX just out of the box with Airflow plugins mechanism. Okay, and then regarding configuration, what we have in our project. So we've tried to have separate configuration and the code to simplify the code and reduce the duplication. So we used YAML config files for that. But from some point, we need more logic on that. So we've implemented this custom tags for YAML parser, and it allows us to extract execution times from our DAG. Also, we could work with Airflow variables and XCOM, so other Airflow functionality, Airflow Ginger templates might be easily handled with custom parsers for YAML. And another useful thing about duplication in configuration files. So basically, we have configs for dev, stage, and production environments, and they are mostly the same, but contain just minor differences in connection strings to databases or root locations for some paths in HDFS, for example. So in this case, we've implemented this approach of including base config and overriding it in a responding environment-specific configuration file. And this approach helped us to reduce the number of mistakes in editing configuration files and reduced code duplication. So yeah, it also saves us a reasonable amount of time. And the next thing about support of the pipelines. Basically, we have different data engineers spread across different teams. And from perspective of support, we have one dedicated team of duty engineers. And at one particular moment of time, only one person actually responsible for restatement of all the failures in our production system. And of course, we have instructors with steps for restatement. But as we know, documentation is outdated almost always. Also, it might not have appropriate formats and standards. So we've tried to utilize the Sphinx documentation with our Airflow pipelines. Basically, we were interested in the names of the DAGs, in the parameters, in the list of inputs, output locations. Also, with this approach, we are visualizing the structure of the DAG. And here is an example. So basically, we are generating the HTML with this Sphinx package. And after that, we are uploading it into the conference as a separate page. And also here, we have just documentation from Python doc strings with signatures of the methods, with links to the source code to the GitHub. So this approach is really useful for support team, since they have one unified format. And from perspective of data engineers, it is also it is easier for us to manage our documentation as a code. You know, and since you could forget to update the conference page, but here in repo you could just have it up to date. Yeah. What else? Also, regarding monitoring, imagine the case when your Airflow cluster is not stable enough for some reason, and you need some external tool for monitoring. So here, what we use, first of all, we are dumping all our logs from Airflow scheduler and Airflow tasks into Elasticsearch. and we might have analytics on top of it just from Elasticsearch. And another thing is Airflow database. We also use it to track number of, for example, running tasks, running pipelines, number of failures, and we visualize this information in Grafana dashboards. We have alerting and notification rules. So it also helps us to reduce time of reaction on production incidents and basically helps our infrastructure team. Okay, and one more thing, which called MetaDex. So imagine it's again the story about simplifying the life of our support engineers. So imagine the case when you have upstream pipeline which generates some data, for example, in HDFS, and also there are a bunch of downstream pipelines which not connected explicitly in Airflow, but actually they have dependencies by data. So in this case, for example, your upstream pipeline fails for some reason, and then we should expect that all downstream pipelines will fail as well. But since they are not connected in Airflow, for support engineer, it might be trickier to perform the restatement in an appropriate manner. So in this case, we've tried to implement this approach of MetaDex. And what it means, first of all, we have a simple file with meta information about dependencies between DEX. So it basically resides near each DEX, and it requires manual efforts to fill these dependencies. And after that, we have separate DEX, which actually looks into all these meta information files and builds the dependency deck. And actually, we have a separate meta deck in Airflow, which represents dependencies between another decks. So what we could achieve with this approach. The first point is visualization of implicit dependencies between decks. And another point is that, again, a duty engineer could easily restart a particular deck just by clicking this task in MetaDeck and rerun fail deck and all the downstream pipelines. So again, in some cases, when you don't have clear dependencies between decks defined with Airflow structure, you could use this approach. Okay, and to sum it up, so in our project, Apache Airflow successfully works as a main orchestration tool. It also initiated the process of unification for orchestrators. So we have positive feedback both from data engineering side and support engineers, duty engineers. So this orchestrator is pretty scalable, fault tolerant. Also, it has a good community. And I'd like to mention that Grid Dynamics actively contributes to Airflow. So we have our custom operators and stuff like that. And regarding plans for the future in our project, right now we are focused on migration from our on-prem Airflow cluster into the AWS solution. And we are looking forward to usage of Kubernetes executors in order to, better utilize our resources and, of course, save money. Okay, and here's a resource slide. You can see a link to Common Pitfalls official page by Airflow. Also, here's an official Slack workspace, and here's a QR code to our Russian Telegram community. We have about 800 members. So join us, let's share our experience, ask questions, and yeah, join the community. Okay, and the last thing regarding our survey, let's just take a look. Okay, we have 24 responses. Okay, and it looks like most of you guys don't use Airflow in your production system. And as for the best orchestration tool, what we have, Airflow is the leader. Also, we have this manual approach. Jenkins also have good numbers. And yeah, some of you use this 9.5 that. So yeah, thank you for the responses. Really interesting. Okay, and let's go ahead and move to Q&A session. Guess we have a few minutes for that. And we have one question in this Q&A form. What kind of operators do you use? Did you have some issues with them, some bugs? What do you think about the concept that Airflow should use only Docker or Kubernetes operators and encapsulate the logic in it? Okay, so regarding operators, in our case, we have Python operators for just basic logic. Also, since we are performing ML processing and just process big amounts of data, we have operators like sparse submit operator. Regarding Docker and Kubernetes, again, it I believe depends on your infrastructure and setup. So yeah, it's a pretty useful approach when you have all the dependencies in all place. You don't have to manage your environment. I mean, Python dependencies, for example. And what else? Yeah, regarding operators, also since we're migrating into AWS, we are using a bunch of operators such as to start TMR cluster, to submit new steps into that. Also, in some legacy systems, of course, we have bash operators, but we're trying to get rid of them and use Python instead. I hope that I've answered this question. Another question, how do you rate the quality of the models, metrics, thresholds, alarms? Yeah, so we use different approaches. First of all, because during the phase when we are building new model, we could validate it on some subset of data and just have these metrics such as precision recall or confusion matrices, and have alerting on that. So in our case, we are exporting these counters and metrics into Elasticsearch and then draw them in Grafana dashboards and have alerting on that as well. And regarding scoring case, we are also trying to compare our predictions with some labeled data from real people, but of course it's not real-time activities, mostly like a validation to double check that overall process goes well. Okay, the next question. I've seen a lot of time that people have daily decks. So in this case, decks will be triggered on daily basis. Is it okay to have minute interval, or Airflow is not designed for near real-time triggers? Well, so in our production system, we use DEX, which runs every 5 minutes. So it works well, but again, it depends on number of DEX and resources allocated for your Airflow master process, since the Airflow scheduler is kind of bottleneck. And there are ongoing discussions and regarding improvements of this Airflow scheduling in general. But yeah, the minutes interval, I think it might work, but so in our case, 5 minutes works fine. We didn't use 1 minute intervals for that. Okay, so I guess we've covered almost all questions. I'll try to answer remaining just later today. So thank you for attention, and I guess we could proceed with the next speaker.